Thank you. Thanks everybody for coming tonight to learn a little bit about how we manage fire in Grand Canyon National Park. My talk is going to be pretty simple. It's basically why are we using fire in Grand Canyon National Park in the first place? Where do we use fire? What kinds of techniques do we use? And the final one, are we actually accomplishing anything? Are we doing anything good with what we're doing? I apologize for this slide. It's the only one that looks like this. But I didn't want to take anything out of context. And this is basically our 2006 management policies. And essentially what it says is that in a lot of the systems that we manage in the National Park Service, fire is a natural part of that system. It helps to maintain the plant and animal communities in some systems. And when we have fire-adapted systems, removing fire from those systems can diminish the integrity of them. What it also says and acknowledges here at the bottom is that we also have systems in the parks that aren't dependent on fire, or they have a very low frequency of fire. And in those systems, we need to also work to maintain the natural fire regime, to maintain the integrity of those systems. And so the question becomes, or what we're charged with, is basically figuring out which systems need fire, which systems need less fire, and how we manage fire in those different systems within the parks that we manage. And the way that we find that out is through research collaborations and through monitoring. And so we're very lucky at Grand Canyon National Park to have a ton of research done on fire actually in the park. And a lot of that has been done here at NTU. And so we have research basically on all of the forest types in the park saying that fire did play a natural role in those systems. And we also have research that says that those systems over the past 100 years have been changed by fire's diminished role. And in some cases, that's changes in forest structure. In other changes, there actually have been changes in species composition in those forests. So we have a lot of research going on in the park, specific to the park, that we can use to help inform our management. The other thing to be said about Grand Canyon National Park is that fires actually occur in the park quite frequently. Okay. Is it still on? Okay. And since they occur, we're sort of forced to manage them. And so this is a figure or map that I'm going to show throughout the rest of the talk tonight. So I want to get you guys oriented. Right here, you see Grand Canyon Village. Out here, Desert View. So this is all in the South Rim. All these squiggly lines, of course, are the canyon themselves. So we have plateau areas on the South Rim, canyon, and plateau areas on the North Rim. So here's the North Rim developed area. Cape Final out here, Point Sublime, Powell Plateau. So this will be the orientation that you guys will be seeing on the maps for the rest of the night. And essentially what I'm showing here is lightning fires from 1935 to 2011 in the park. And so what each one of these blue dots represents is a fire that was started by lightning in the park that put up enough smoke that somebody actually saw it, gave it a name, and put it on a map. And so I would say that this is a conservative estimate of the fires that have started in the park over the past 70 years or so. And you can see what I think is interesting about this is the distribution of where these lightning strikes are. You can see we have very few lightning strikes in the canyon. We have a lot here by the village out toward Grandview, a lot on Powell Plateau and these other plateaus that sort of stick out on the North Rim, and fewer lightning strikes out in this area near Pasture Wash, Desert View, and up in the higher elevation areas of the North Rim. So what does this mean kind of in the long term? Basically, on average, we have 22 lightning strikes that start fires above the rim on the plateau areas every year. Our maximum year was actually 1988, where we had 91. Almost half of those were in June. So some years we get a ton of lightning strikes. And our minimum year was 1935, and I have to say that I think maybe they didn't keep very good records in 1935 because they say that there was only one lightning strike, and I think that's the only year in our database that occurred. So lightning occurs on the landscape. We have lots of research saying that it was historically important, and we have research saying that changes have happened because fire wasn't on the landscape. So what kinds of vegetation types am I talking about? Where do we actually use fire? And so here again, we're talking about the above rim plateau areas, and we basically can divide that up into 4 pretty broad vegetation types. We start at the lower elevation with pinyon juniper vegetation types in this area and this area. Move up a little bit higher to ponderosa pine Village and out toward Grandview, ponderosa pine on the north rim, on the plateaus. And as we move up in elevation away from the plateaus, we get this light blue mixed conifer and the darker blue spruce fir forest. And so what do these look like, and what are the characteristics of those? The pinyon juniper forest, basically it's pinyon pine, Utah juniper. There's a few ponderosa mixed in there, some gamble oak. And these are essentially, when we're talking about fire in these systems, we want to know what are the fuels that are going to burn the fire. So what's on the surface? We're essentially talking about conifer litter, sticks, logs, things like that. And in this pinyon juniper forest, we see a lot of rocks, a lot of bare ground, not a lot of continuous fuel. So we're not going to get those continuous surface fires in this forest type. This is going to be more, maybe this log is going to burn and burn up the trees beside it and send some embers out to other areas, but not a continuous burn and not a very frequent burn interval. So this is a pretty long burn interval. It can be hundreds of years before a piece of this forest burns more than once. Moving higher up in the south rim ponderosa pine, we have mostly ponderosa pine. We do have some pinyon pine, some juniper, and some gamble oak in this system too. And this system, the surface fuels are basically leaf litter. So you get this continuous layer of leaf litter. You're going to get continuous low intensity fire. You can also see in the ponderosa pine, the branches are pretty high off the ground in most cases, and so these trees are going to be able to survive low intensity fires. And the fire return interval in this system is going to be basically 10 years or less. So every 10 years or so, you expect historically to see a fire in this system, and that would be a low intensity fire. We also have ponderosa pine on the north rim. It's essentially the same as ponderosa pine on the south rim, except for it also has some white fir in it, quaking aspen, things like that. We do seem to get a few more logs on the north rim too, but still we have a moderate dead surface fuel loading. We still have dominated by low intensity surface fires that sort of spread throughout the forest. As we move up higher in elevation, we start to get into more mesic species, so we start getting more white fir, Douglas fir, we get some spruce and what we call mixed conifer areas. And this is going to be dominated by much heavier fuel loading. You're still going to have the litter layer, but lots of logs in these areas. And so you can see, these logs have the ability to generate higher intensity fires. We have trees that have branches that go all the way down to the ground, so there's more of an ability for those trees to torch out. And so in the mixed conifer, you're going to get a mixed severity result. So you're going to have some patches that burn with really high intensity and kill some patches of trees, and some patches that burn with lower intensity. And so this is a little bit longer fire return interval, on the order of decades compared to the ponderosa pine. And then when you move higher up, you get the spruce fir forest, where you get these trees with branches that are essentially on the ground, lots of heavy fuel loading, and these forests basically collect fuel for a very long time, and they burn with long return intervals. And so you could be up to 300 years in some cases 100 years, some cases 50 years. So this is a really patchy burn area, and you can again get intense patches of high severity effects in the spruce fir. So those are the areas that we actually manage fire in. And so then the question becomes, what is it that we actually do? And this is a map of our fire management strategies. And essentially our fire management strategies are based on where you are in the landscape, whether you're close to values at risk, and also what vegetation type you're in. So if we start down here in the easiest area by the village, you see this bright red. This is what we call our wild-urban interface. So here we're around buildings. And essentially what we do here is we can do some prescribed fire, and we can do some thinning treatments around buildings, but we can't allow wildfires to burn in those areas. There are too many people, there's too many buildings. It wouldn't be a safe thing to do. As we move out from there, we have this peak area, which we call our secondary buoy. In this area, we do pretty much prescribed fire only. We also don't allow any wildfires to burn in those areas, and we don't do any thinning in those areas. They don't have any buildings, but they're still close enough to the buildings that we don't want to allow wildfires to burn. As we move out further, we have these areas in brown, green, yellow, and blue, and these are areas where we can utilize prescribed fire or wildfire to achieve our restoration and maintenance objectives in those forest types. And then we have what I think are these great areas, kind of in light blue up here, these plateaus. You can see that these are isolated plateaus kind of in the middle of nowhere. They're not touching